Now, we have spoken to a lot of people, a lot of consultants, engineers and designers, people who work with architectural acoustics, and we consistently hear that one of the biggest pain points they face is the very time-consuming process it takes from going from rich, complex, detailed architectural models, like the one I have on the screen here, for example, to simpler models which are suited for simulation. And often in projects, more than half of the time goes into this geometry cleanup step. And this is something that we set out to address here in Treble. More than 2 years ago, we built a dedicated team around this challenge. And now we are introducing an automatic process that can take the complex BIM models and automatically split them up into separate spaces and automatically simplify them and make them suited for acoustic simulations. I think this will be a massive workflow improvement for our users so that they can spend their time more on acoustics and less on 3D model cleanup. Now, I will say already now here in the beginning that this is a very challenging task to develop an algorithm that can do this task for us. And the sort of edge case space is very wide. BIM models come in a variety of flavors and so on, and there are so many imperfections in them and so on. So in some cases, this algorithm works perfectly. In other cases, it works very well, but not perfectly, but it will get you maybe 80–90% of the way to a simulation or simulatable model. And then the process would be that you import it into Treble, get it automatically simplified, pull it back to SketchUp, do the last finishing touches of the cleanup, and then back again into Treble. And I will show kind of both cases now. I will start with a more simpler model, which is also just a bit more kind of cleaner way to demonstrate the process, show you how I go through the step of importing it, having it separated into spaces, simplified. Then I'll quickly set up a simulation and actually an oralization, just to kind of show the whole workflow and how quickly one can go from a BIM model to simulation results, essentially. Then I will apply it on a more complex model, actually this model I have here on the screen, where we will see that the algorithm does a really good job of separating it out into spaces and simplifying it, but it's not entirely perfect, so I pull it back into SketchUp, do the last finishing touches, and then I'm good to go. So let's dig in. Starting with this bit simpler model, it still has a lot of geometric details. I mean, look at these railings here on the stair. Look at the legs on the chair. There's holes between the windows and the walls and so on. So typically, up until now, the process would be to kind of start from scratch, drawing this model up in SketchUp or Rhino or something like that. But now I'm going to import it into Treble and work with it directly. Here I'm opening up Treble. It might look a bit different for people who have used Treble in the past because we're also overhauling the look of it. I'll come back to that later, but now I'm just going to show here. I go to import geometry. I have this IFC file, this BIM file on my computer, and I simply drag and drop it here and press upload. Now this gets shipped to the cloud and the geometry algorithm takes over and starts splitting it up and simplifying it and so on. This step does take a couple of minutes because it's a very complex task that's happening under the hood. So just in order to save some time, I already started an upload a couple of minutes ago, so I can show you here once this is done. Then I would be faced with this view here where I can see the different spaces within the model. I can see that details have been simplified. For example, the railings are gone now. And I'm ready to import this into a project. I'll just create a new project here. And I'm good to go, essentially. I've already run a couple of simulations in one of these spaces here earlier, just to save us some time. Let me show you quickly how that looks and how we can oralize one of these spaces. So we'll go into a different project here and open this up. So I This is the kind of attic living room space. It's been merged into one model because it's acoustically coupled, these two spaces here. You can see how the railings are gone, the chairs look much simpler, it's watertight, so the holes here between the windows and the walls are fixed and all of that. I went through the regular steps of first assigning some materials, throwing in a couple of sources and a few receivers and setting some settings. This setup step took me maybe 1 minute, and then I ran the simulation that took around a couple of minutes to run, and I'm basically ready to explore some results. I simulated it with and without some acoustic treatment. And we can see here that it's more reverberant without this acoustic treatment I put in. And I could, of course, explore all kinds of results and so on here in the results view. But instead, I'm also just going to quickly listen to the space. So I go into our oralizer, where I can put up the comparison between the two cases I simulated. I add some sounds on the sources here. Maybe some group dialogue, for example, onto the two different sources, like so. And then I can simply jump into the space and I can hear how it's going to sound with these two conditions. And then the icing on the cake, I could click the share link here, call it design proposal or something like that, and then generate a link to this listening experience, which I've done now. Share this link with, for example, my client, like so, and the client, she could just go receive the link. She doesn't have to be a Treble user or anything like that, and she can just experience the listening experience like so. So I've kind of shown going from a BIM model, having it automatically simplified, prepared, separated into spaces, a couple of minutes of setup to run the simulations, and then a listening experience on the other end, the whole thing taking around 10 minutes maybe or something like that. I think this, well, at least I think it's very cool. Let's now apply it on a more challenging case, a very rich BIM model and complex, large and so on, which we see here. I have already imported it just to save us some time. This time the importing process took a few more minutes than for the smaller model as expected, but still nothing too bad, just a few minutes. And it successfully separates this big office model into several spaces, and they've been simplified and so on. So let me show you here. This project is over here. It's around 75 spaces in total that are within that model. And I'm first going to show you this cafeteria space, which the initial import looks like this. A lot of details have been simplified. Again, look at, for example, the furniture in here. This model is ready for a simulation. However, the simplifying algorithm did not do a perfect job. Note, for example, that there's a little bit of junk outside of the model here. And the model in this case was not perfectly watertight. So this means that I can only run a GA simulation on it right away. But still, that's a very impressive feat, I would say, importing this very complex model, automatically separated, simplified, and GA simulation right away. No manual labor needed. But if I wanted to go the extra step of running a wave simulation on it, what I would do is I would go back to SketchUp, fetch the model into there, do the last touches on the cleanup, and then re-upload. Let me show you real quick. Now, here I am in SketchUp. The Treble plugin is open. I just click this Fetch Geometry button. I find this project and the space in question. And this is the initial import from the automatic algorithm. I get it here into SketchUp, And then I can do the last finishing touches, like deleting these extra things out here, finding out where the hole is, plugging that up. Took me around 10 minutes to do the final cleanup. I used the checking algorithm to help me find the issues in the model, and then I re-upload it to the software, and we can see the watertight cleaned up version here. So, complex large models, no problem. The algorithm gets me, in this case, 80–90% of the way, and I do the last touches here. This was a relatively small model, or sort of small space within the model. Let me show you an example of another one, which is much bigger, where the algorithm, let's see, where is this? Here we go. This is a big atrium spanning several floors, connecting corridors and so on. It would probably taken me a couple of days to build an acoustic model for this from scratch, but the algorithm did this automatically for me. It merged several spaces within the BIM model because they are acoustically coupled, and I can immediately run a GA simulation on this without any extra work. And like before, if I wanted to do a wave-based simulation, some minor finishing touches would have been needed here. This algorithm, this automatic simplifying space extracting algorithm, will only get better and better with time. I will also mention that as we train it on more and more models. Okay, this was the quick intro to the BIM IFC importing automatic extraction simplification process that we have built. We really look forward to putting this out to the world and getting feedback, and we certainly hope that it will make the lives of people working with acoustic simulations more fun, more effective, and so that they can spend their time on acoustics and not on geometry cleanup.